Welcome back to another video. It's Dr. Tarcia Hubert here, your favorite math professor. Alrighty, in this video, we're going to talk about observational studies versus design experiments. And so again, we're talking about some statistics. We're talking about collecting data, research, all of those good things. And so the first thing we want to discuss before we get into these two types of experiments first thing we want to talk about is the different types of variables you can have in a study. There are two of interest right now. We'll talk about a few others in a little bit, but the two that we're interested in right now are your explanatory variables, also called the independent variables, and your response variable, also called the dependent variable. The explanatory variables are the variables that can be altered or manipulated in research, and they're often used to explain or predict differences in the response variable. All right, so these are the things that you change in an experiment or that you're watching, the things that you're watching in an observational study. A response variable is the outcome of that thing that is predicted or measured following the manipulation of the explanatory variable. All right, so explanatory variable is the thing that's changing, and the response variable is you're looking to see what happens because of that change. All right, for example, a researcher wants to assess the risk associated with smoking cigarettes by looking at a group of people, determining how many are smokers, and comparing the rate of lung cancer of the smokers to the non-smokers. All right. Now, there are probably a lot of questions that are going through your head when you read this because all the details aren't here. This is just the overview of that study. They want to look at a group of people. They want to determine how many are smokers, how many are non-smokers, and then they want to compare the rate of lung cancer of the smokers to the non-smokers. So the explanatory variable here is the people smoking cigarettes, the smoking of cigarettes. So we have the smokers versus the non-smokers. So we're trying to see if smoking explains the response variable, which is the rate of lung cancer, okay? So the thing that's changing here is whether they smoke or they don't smoke. That's your explanatory variable. And then the response variable is whether they have lung cancer or not. All right, so hopefully this helps in identifying and seeing the difference between the explanatory and the response variable. So there are lots of ways you can collect data, but there are two particular types of studies that we're going to look at in this video, and that is an observational study. An observational study measures the value of the response variable without attempting to influence the value of either of the response or the explanatory variables. Now, look at this image that I selected over here of this guy holding this magnifying glass. And I chose this image because look at his hands. They are holding the glass, and all he's doing is looking through the glass. He's not doing any work because his hands are holding the glass. All he's doing is observing. So in an observational study, that is all you do. You're not giving the participants anything. You're not manipulating anything. All you're doing is observing what participants already go through in their normal lives. Now, there are some things, which we'll see an example in a minute, that there are some observational studies that require participants to do something. But for the most part, in an observational study, the researcher isn't conducting anything. They're just observing. All right. Some advantages of observational studies is that they typically have lower costs because you're not giving participants anything. So you don't have to buy anything. You don't have to invest in anything. All you're doing is observing. Participants are already in their natural habitats. And so the costs are typically lower and the timeliness of it is usually better. Like it can be quicker because you're not giving participants anything. You don't have to wait for them or something to take into effect. Like usually you can observe them right then and there, get the data that you need and analyze it. And you usually get more people to study when it's observational. Think of a survey. A survey is an observational study. You usually get more participants from a study, and you usually get more participants from a survey versus having people come in to do an experiment. All right. So those are some advantages. Of course, there are more, but those are just a few that has been pointed out in research. And then one main disadvantage is that with observational studies, you cannot claim causation, only association. Now, what does that mean? That means you cannot claim that the explanatory variable causes the response variable. So in our example earlier, If we were only doing an observational study and we found that those smoking cigarettes get lung cancer at a higher rate than those that don't smoke cigarettes, we cannot claim that smoking cigarettes causes lung cancer if it's an observational study, okay? Because there are some limitations to observational studies, which we're going to talk about in just one moment. But causation is really, really important. If you think about it, when you find out that someone in your family is sick or they have developed some type of disease, such as cancer, one of the main things we want to know is what caused it. And so causation is a really, really big thing with research. We typically want to know what causes something, and observational studies do not allow us to make those causation claims. Now, the reason we cannot make those causation claims is because with observational studies, you cannot control variables, and therefore you may get what's called confounding. This occurs when the effects of two or more explanatory variables are not separated. So there could be some other type of variable explaining what's happening to the response variable. All right, and this may be due to some variable that's also in the study, or it could be due to some variable that we didn't even know about. Okay, so and that leads us to our two next types of variables, which are confounding variables and lurking variables. Confounding variables are explanatory variables that were also considered in the study, but could also possibly explain the effect that's happening to the response variable. Alrighty, it wasn't our explanatory variable of interest, but it was used in the study. It was measured in the study, and I'm going to show you an example of this in a minute. And it could also be an explanation to what's happening with the response variable. Now, on the other hand, we have lurking variables, and these variables can also be used to explain what's happening with the response variable. But the difference between the lurking variable is that it was not even considered in a study. All right. For example, with the lurking variable, I didn't put this on my presentation, but with the lurking variable, such as in the cigarette example, if we had the study where smoking cigarettes, people who smoke cigarettes had high rates of cancer, lung cancer, it could be other factors explaining that cancer, such as the participants' health history, their weight. It could be their genetics, like whether cancer runs in their family or not. So there could be other variables that we did not consider that also explains the effects of the response variable. Hopefully that makes sense. Here's another example. A professor wanted to conduct an experiment to study the effects of homework type on student success. So what the professor did was, with their morning class, they used online homework, like what we do in our class. They used online homework with the morning class, and then they used traditional textbook homework with the afternoon class. And then at the end of the semester, she compared the final exam scores from the online homework section to those of the traditional homework section. Now, if the morning class had higher exam scores, can the professor conclude that the higher scores were due to the online homework? What do you think? Is that enough for her to conclude that the higher scores were due to the online homework? If you said no, you are correct, because there are other variables at play here. And I put this up. The time that the class was offered could also be a variable of play here. And I can tell you this from experience. Students who typically register for morning classes are more motivated than students who register for afternoon classes. I've seen this time and time again. Students who want to do their classes early and get them out the way, those are usually your motivated students. And students who take the classes in the afternoon, those are usually your less motivated students. I'm not going to say lazy, but they don't want to get up early. They want to sleep in. They want to do what they want to do, and they want to come to class in the afternoon. All right. So the time that the class was offered, it was taken into account in the study. It was measured. So, and it could also explain the response of the higher final exam score. So because it was measured, the time that the class was taught would be considered a confounding variable. All right. So if there's another variable that can possibly explain the response variable, if that variable was used in the study, it's confounding. If that variable was not used in the study, it's lurking. Let me know if you have any questions about those. Now, on the other hand, we have a designed experiment. A designed experiment is when a researcher assigns the individuals in a study to a certain group. So that's usually the first key that lets you know it's an experiment. That is when the researcher puts the individuals in groups. All right. Then the researcher intentionally changes the value of the explanatory variable and records the value of the response for each group. So typically in these experiments, you have what's called a control group. That's a group where nothing is happening to them. And an experimental group, that's a group where you're giving them some type of experiment with. And then you compare the results at the end to see if the group where nothing changed with them, you didn't change the variable, is different from the group where the variable was actually changed. Okay. So these are considered designed experiments. And advantages of design experiments is that you can in certain experiments, we're going to talk more about when you can and when you can't later. You can identify certain cause and effect relationships among variables in design experiments. So it allows you to make that cause and effect relationship. And then some disadvantages are design experiments can take time and they can be really costly. Okay. So those are some advantages and disadvantages. So let's look at some examples and let's see whether these are observational studies or design experiments. Example 1, the American Cancer Society is beginning a study to learn why some people never get cancer. To take part in the study, a person must be 30 to 65 years of age and never had cancer. The study requires that the participants fill out surveys about their health and habits and give blood samples and waist measurements. These surveys must be filled out every 2 years. The study is expected to last for the next 20 years. Do you think this is an observational study or a designed experiment? If you say observational study, you are correct. The researcher is only observing the patients. Now, in this observational study, the patients, and this is what I was talking about earlier, the patients actually have to do work. They have to give blood samples. They have to take waist measurements. They have to fill out surveys. And this one actually takes time because it's lasting for 20 years, which some observational studies don't last that long. But this is an observational study because the researcher is only observing what is happening to the patients over time. Example 2, rats with cancer are divided into 2 groups. Divide them into groups, hint, hint. One group receives 5 milligrams of a medication that is thought to fight cancer, and the other receives 10 milligrams. After 2 years, the spread of the cancer is measured. Do you think this is an observational study or a design experiment? If you said design experiment, you are correct. And it is a design experiment. So the hint in the first is it was divided into 2 groups. And then you're giving the participants something. You're giving one group 5 milligrams of medication. You're giving another group 10 milligrams of medication. And then you're seeing how does that affect the spread of the cancer. All right. And this is another reason why sometimes you have to do observational studies because experiments aren't always ethical. So this experiment is done with rats, but it wouldn't be ethical to do this experiment on people. So sometimes observational studies work better because the experiment of that would not be ethical. Example 3, a survey is conducted asking 400 people, do you prefer Coke or Pepsi? What do you prefer, Coke or Pepsi? Me neither. I'm not a soda person. But this was given to 400 people. And they were asked what they prefer. What do you think this is? If you said observational study, you're correct. All they're doing is observing whether people like Coke or Pepsi. They're not doing anything, not giving them anything besides the survey. And then the last example, 7th grade students are randomly divided into 2 groups. Divided into groups, hint, hint. One group is taught math using traditional techniques. The other is taught math using a reform method. After 1 year, each group is given an achievement test to compare proficiency. Is this a observational study or a design experiment? If you said design experiment, you are correct. They were divided into groups. One group was taught using one method. One group was taught using another method. So that is your experiment right there. And then at the end, they take a test and you compare the results. And so those test results are your response variable. All right. So this is observational study versus design experiments. Hopefully it makes sense. If it don't, ask your questions in the comment. I will respond as soon as I can. And if you haven't already, go ahead and hit that subscribe button to subscribe to my YouTube channel. I will see you all in the next video.